All right. So today we are going to learn IPv6. How many bit is your IPv6? Huh? 120. So how many addresses you get? 2 to the power of 128. Okay. So your IPv6 address will be like this. It is like this. See, 2000. It is divided by semicolon, correct? So 0DB8 0001 0000 0000 again 000A 1 2 3 4 5 6 1. In your IPv4, we say it as octet, correct? In IPv6, what we will say? Hextels. And each bit is called as hextet. How much is one hextet? 16 bits. Okay. So see this 0DB8. That means 0DB8. So how actually it is, how your system is going to understand this zero means it is going to understand it as 0000. What is decimal of D? What is the decimal of D? 13. So what is the binary? So 8 plus 4 plus 0 bit is off and 1 bit is on. So 1101, correct? What is B? 11. What is 11? 8 plus 2 plus 1. So 8 bit is on, 4 is off, 2 is on, 1 is on. 8 means 8 is on, 4, 2, 1 is off. So this is what your system is going to understand as you write a 0DB8. Okay. But is it possible for us to write the complete IPv6 address in bits? No way. Then you have to write 128 bits. So that is why your IPv6 is in hexadecimal format. Okay. And you get so much IP address as that somewhere they believe that it will never go exhausted for at least 70 to 80 years. And each person can also be given the public IP instead of private IP, so that there is no translation. You remember the last class we did this static NAT, dynamic NAT, and then PAT. In static NAT, we are using one individual IP for one private IP, and in dynamic, a pool of IP will be created so that you'll be able to use that IP. And then what? PAT. One IP we are using as the public IP for all the private IPs. So that concept itself is not there in your IPv6. Okay. Write down the binary of this. CE9A. Online guys, you can post the answer on the chat window. Kanni. Written. Okay. Let online guys also do it and post it on the thing. CE9A. Write down the binary. Online guys, I need 5 answers on the chat window. Ahmad, Mohammed, Nibil, Prashant, everyone. Post it on the chat window itself. Only one person. What about others? Only Prashant has sent it. Others, are you there? Mohammed, Parveez, Nibil.
Yes, sir. Hosting.
Yeah, post it, post it. Offline, everybody done? Who's doing still? Dinesh done?
Done, sir.
So C means what?
12.
12. So 8 is on, 4 is on. Other two are off. E means 14. So 8, 4, 2 is on, 1 I'm going to turn it off. 9, 8 is on, 4, 2 off, 1 on. A, 8 off, 4, 8 on, 4 off, 2 on and 1 off. How many of you got it right? Be honest. Very. All right, very good. Okay, guys, very good. So there is a shortening rule in your IPv6. Okay. So 01, 0, DB8. I'll give time to write. Just listen as of now. What happened?
Second last.
This one. How many extras are there? Extet? 1, 2, 3, 4, 5, 6, 7, 8. 8 are there, correct? This is first one. First thing we're going to learn is that is shortening rule in your IPv6. So this shortening rule in your IPv6. This thing we don't have it in your IPv4, only in IPv6. So first thing is eliminate the starting zeros. Okay. Eliminate the starting zeros of each octet. Okay. So, sorry, not octet, hextet. So 2001, write it 2001, 0 db8. So eliminate the starting zero so that you will write it as db8. And then you have 0010, that will be written as 1. So eliminate the starting zeros, 10 it will be written. And then 0001 will be 1. See, we have 4 zeros, but it should be written as 0 only. Okay, you can't completely remove the thing. So you'll be writing it like this. And then semicolon 0, and then 1. So this is the first condition. Second condition is replace the continuous. Replace the continuous zeros as double semicolon. Okay. So write it same way, 2001 semicolon db8, and then we have 10, and then we have 1, and then we are having 30. So I'm writing it as double semicolon and 1. Okay. Understood this? So I'm having continuous zeros, 0, 0, 0. So that is the reason we are writing it like this. So another one more thing important here, you have to note it down. That is, I'll write it as note. Only one time this rule is applicable. Okay. Only one time this rule is applicable in an address. See, for example, if I'm having an address like this, how many we have? Okay. So see, first of all, I'll explain you this, then we'll see the other one. So initially I've removed all your zeros in the each extent of your IPv6, and then I'm saying continuous, semicolon in place of continuous zeros. So here I'm having two column, semicolon. So that is 0. So how many extracts are there here? Count it down. 1, 2, 3, 4, and 5. So 5 extracts we already have in the address. So this double semicolon means, so how many extracts are remaining? 3. So your computer will understand that there are 3 zeros in between. Okay, anywhere you use this double semicolon in the address, IP address, so that the system is going to understand that as the missing exits as the continuous zeros. So why this rule is applicable only one time? See, for example, if I'm having an address like this.
If you have, sir, win gap, they will computer will not understand.
Correct. So I'm having an address like this. Okay, if I'm going to write 2001 semicolon, double semicolon, 1, double semicolon, again 1. Okay, how many exits are there here? 3 are there. So how many remaining? 5. So your system will get confused that should I take the first 3 octets as the zeros or the last 3 hexets as the zeros. It can also write it down like this, right? Correct. It can also write down like this, right? Which is wrong. My zeros are in the second half, not on the first half. Okay, so if in case if you have an address like this, the continuous 3 zeros here, right? This will be written it like this only, but here it will be 0, 0, 1 and double semicolon. Like your address will be there. So 2001, 0, 0, 1 and then double semicolon. So this is the reason we don't use this rule twice in the address, even though if you have continuous zeros twice. Okay, any doubt on this? See, instead of writing it like the address as like this, we have made it like this. So this is called your shortening rule. Okay, write it down.
The body speed of 1 is 0.
Where?
2001, 0, 0, and then also 1 is there.
This one. If it's 0, then you'll write the address like this. Very simple. 2001 double semicolon 1.
Then it will not
Take 2 octets are there. So that 6 are remaining. So 6 will be zeros. Write it down.
In IPv6 address, each set have 4 hexadecimal compulsory or not?
Exact. See, everything will have 4. But if you have 3, then you have to assume that 0 is in between, in the starting. So here what I have written, DB8. That means there is 0 in before. So 0, 0, 0, 0. So D means what? 13. So 8 will be on, 4 will be on, 2 will be off, and 1 will be on.
In the first address, in 7th state, 1 bit is missing, so that's why.
Oh, this one. Okay, I missed it. Right. Who had HR interview yesterday? HR interview. Someone was telling about HR interview. Oh, Himanshu. So HR has assigned for you. You said.
HR contact me for the technical interview.
Mm-hmm.
That's what I answered.
Yeah, yeah. Sometimes these HRs no, they'll simply ask questions. Though that is sometimes it's not required, they will, you know.
It will not form the networking.
I know. They'll simply say, I'm busy, I'm having work. So can you please contact tomorrow? Like that they'll do. See, they don't do anything technically. Simply say they kind of manage things. Correct? We're HRs. But every details they have. Today, what interview we have? On what topics? Routing, right? No? On OSPF, I said, right? I was just joking. Don't worry. Written this. Any doubt on your shortening rule? Can now come to PPT. See here. How many IP addresses are there in IPv4 and IPv6? There are so many in your IPv6, correct? Yeah. And here you can see IPv4, which is IPv6 size difference. So this is 32-bit, this is 128-bit. And then octet, here it is hextet. Okay. And then IPv6 converted to binary. See, look at this address. Is it possible for us to write like this? No. So that is the reason it is in hexadecimal. So here if they say, here we don't have subnetting in your IPv6. There is no topic called subnetting. Here /64 they are saying, right? So first 4 extents are will be belongs to network part and other belongs to host part. So this completely will keep changing it, but this will be fixed. Okay, that is the difference. /64 means how many bit wise you have to calculate. Okay, so first 4 are called 16, 16, 32, 48, 64. So that's why this is network and this is host part. And then shortening rule we have seen now. Correct. All right. Conversion of market. Tables are there. Write down this one in your note copy. written. So your global unicast means what? It is your public address. Like your public address in your IPv4, we have public address. Likewise, global unicast means public address. Unique local means your private address. Okay. So this is public, this is private. Multicast address we have in your IPv4 also. Same likewise in IPv6 also we have multicast address, that is one to many. Okay. So this link local address is, here you can see publicly routable WAN, routable in the LAN, that means for our private users. This is for particular group, you can do it. And anycast means what? What kind of communication is your anycast? One to the nearest, that is one to one, one to the nearest one. Okay. That we know. For that purpose, we are using this same range shared address. So whichever is nearby, it will get connected to that. So that option only in your IPv6. We don't have in your IPv4. Okay. Link local address. What is this link local address? By default, this IP is in your PC or your device. Okay. So what is the use of this? It is to communicate within the network. If your DHCP failed, then your APIPA will come into picture in your IPv4. Whereas in your IPv6, you have this link local address that is not routable. It cannot communicate to other network, but within the network for the neighbor discovery. So those kind of things we are using this link local address. So how we are getting this link local address? See, I am taking a PC. Here you can see IPv6 configuration, right? Underneath, here you can see link local address. Correct? There is one link local address here. How we are getting this link local address? So randomly you can't get it, right? So there must be some rule. How we are getting it? That we will learn now. So first copy the MAC address. Paste the MAC address. Okay. What is the first rule? That means add FF semicolon FE in the center of the MAC address. Okay. So 00 D0. What is center here? So this side we have 6 and this side we have 6. Correct. So in between I'm going to write it 0 semicolon BC FF FE what? 80. And then we have 3B A1. Okay. Like this we are going to write it. Okay. Any doubt on this? So in center I'm going to write it. Okay. After that, next rule is inverse the 7th bit. Inverse the 7th bit. What is the 7th bit here? See, 0 0 is there. So 0 means what? What is the binary of 0? 0 0 0 0. Correct. Next one again we have. So what is that 0? 0 0 0 0. So what is the 7th bit here? 1 2 3 4 5 6 7. So this is the 7th bit. Correct. I'm going to inverse that. That means 1 0. Likewise, I'm going to write it. So what it will become? 0 will be 0, but this will become 2. How 3? 2. And then we have D 0. D 0. And then write down completely just like that. Okay. This is the second rule. Next one, that is add FE80 double semicolon in the beginning of the address. So what it will become? FE80 double semicolon copy paste. After this, apply the shortening rule. Apply the shortening rule. So what is the first rule in your shortening? Eliminate the starting zeros. So I'll eliminate the starting zeros. After that, continuous zeros I have to replace with double semicolon. But is there any continuous zeros? Only one thing is going to change. That is, just I have to eliminate this one. Okay, so how many octets are here? The extents are there 1, 2, 3, 4, 5. So here in between, how many zeros are there? 3 zeros are there. Understood this? So now go to that PC, desktop, go to this one, copy this and check. Is it correct? Same. So this is how you're getting the link local address in your IPv6. It's not like a random value. So we calculate it using our MAC address. So there are rules. According to that rules, you will get this link local address.
What is use of that link local?
To communicate within the network and to find the neighbor. If there is any neighbor and you don't have the IP, then you can communicate it through this link local address. Okay. Any doubt on this? No. Write it down. API, see, for example, yesterday we did the DHCP, right? If your DHCP configuration is failed, then your system will be assigned with the API address. That is like a fixed IP. It starts from the range 169. Okay. So Monday you are going to do research on API address and come. I will ask questions. It is good to know. I will explain you and you also do your research and come. What is API address? API PA. And write down this one.
That means again, even the seventh bit is read.
Yes.
Only fourth fixture is going to change.
Only fourth extent.
Mean the 0 to D0.
This one.
Second rule, second rule.
This-
Include the seventh bit.
Yeah.
Not
Seventh
the-
bit means this is the seventh bit, right? Because here it is in hexadecimal format. If you change it to bits, then this is what? 5, 6, 7, 8 bit is here. I'm inversing only the seventh. If it's 1, you have to change it to 0. If it's 0, you have to change.
Only 0 to D0, not in others.
No. Only in that one.
In the first thing, sir, why after putting sir at at zero, why you are putting double colon, not single colon, sir, after adding?
Where? Here?
Yes,
What you're asking?
sir, I'm asking the original address is written over there, and we have to add FF colon FE only.
FF colon. Actually, you have to add FFEE. You have to add triple FE in between. So if you add, it will become like this. So this two will take first F and 80 is back so that FE will come into picture here. So adding it in the middle.
So then we I think it will turn from decimal to colon.
Yes, yes, yes. Decimal to colon, it will change it.
Yes, sir, that this is what I'm asking.
Okay, yes, yes. Written? Writing still? Who's writing? Write down quickly. How many of you want class tomorrow? Same time.
Yes,
If everybody are okay.
same ongoing. Yeah.
What about others? Okay, no class. So only 3, 4 are interested. Okay.
Till Tuesday, we go sir.
Yes. 1, 2, 3, 4. No class. Everybody has to accept because your course itself, it's not on Saturday and Sunday. If you have to take, then it should be like extra class. Huh?
We have to sit 3 class now.
Monday you have 3 classes. What class is starting? Oh, switching is starting on Monday. Oh shit. Okay. Okay, I'll let you know. If possible, we'll do online only. Because all are theory only. Huh? Offline is there, but huh? What? What are you saying? You can't understand. Okay. No, there is no practicals. Only theory part. Next class is complete theory. No practicals. Hmm. Okay, I'll let you know. Because I have to also see because Christ class is also going on. I don't know if they may assign to me. If in case if they assign to you, I'll let you know in the group. Okay. So this is the link local address we have seen. And then conversion of MAC address to link local address. We have seen this. So add triple FE in the mid and then inverse the 7 with add FE80 and then replace with colon and apply the shortening rule. You will get the link local address. After that features, there is no broadcast traffic in your IPv6 like 255, 255, 255. No, no such thing. And then auto config for stateless and stateful. That is your DHCP v6 you have that you will learn in your advanced topics. Okay. And then no NATPAD directly you can use it. So the IP address itself, it supports IPsec. What is this IPsec? You use it in the VPN for security purpose. That is encryption. Everything will be done in this protocol. After that, header is improved in your IPv6 compared to your IPv4 and any cast support is there. That is one to the nearest. So these are the features of your IPv6. Now we are not completely moved into IPv6. Now your ISPs, some ISPs are trying to, change it to IPv6. So once complete ISPs, internet side, they change to ISP, then we will also change. Okay. Until then, you have to read translations. Okay. So we'll see one practicals. That is, we'll see one routing of IPv6. Simply take 2 routers. So here I'm going to take 2,000,000/64 as the network here. So that IP will be 2,000,000/1. Here, double colon, sorry. Double colon 2 will be the IP here. I will add some loopback addresses. 2,001 double slash 1. Okay, slash 64. Everything is 64. Network is 64. So one IP. This is one network. This is another network. This is another network. All are 64 slash. Okay. So I'll quickly go and do the configurations. Interface gig 0/0. IP address 2,000 double colon 1. Okay. Slash 64. It is saying error. That means there is only one thing you're going to change. What you're going to change? Instead of IP address, you're just saying it as V6. Wherever you see IP, what we are saying, do show IP address. So in your IPv6, you say do show IPv6 address. That is the difference. And say no shutdown. See, do show IP interface brief will not show you the address. Instead, you have to say V6 interface brief. You will be able to see the address. Okay. First one is link local. Second one is your actual interface IP. Now come to this router. IP V6 address 2,000 double colon 2 slash 64. Say no shutdown. And say do ping 2001, sorry, 000 double colon 1. 100% pinging directly connected. Now I will add the loopbacks. Interface loopback 1. IPv6 address. What is the address? 2001 double colon 1 slash 64. And then interface loopback to IPv6 address 2002 double colon 2 slash 64. Interface loopback 3 IP address 2003 double colon 3 slash 64. Oh, what is the mistake? IPv6. Done. Now exit. Now go to this PC and ping 2001 double colon 1. Why it is not pinging? Because that is a different broadcast domain and we need routing. What doubt? So I will do static routing. So I'll say IPv6 route. In IPv4, we say IP route. Here I'm saying IPv6 route. So what is the network? 200. So IPv6 route 2,001 double colon slash 64. This is the network, correct? And what is there is no subnet mask here. So we don't have to, that's why we are giving slash 64 directly. And we have to give the next stop. What is the next stop IP here? This one, 2000 double colon 2. Done. Now try to ping 2001 double colon 1. See, now it is pinging. Now I'll try to ping. Is it pinging? It will not ping because routing is not given for that. Correct. So I'll say IPv6 route 2. And another one is 3. given. Now I'll say do pinging 3 3. Okay. So this is how you can do your static routing in your IPv6. If it's like EHRP or OSPF, then what? Same thing. You have to say give the network in terms of network. You're going to give this IP. Give the network. That is 2000 double semicolon /64. Okay. I'll give you the commands. You can write it down. So this is command is for routing. This you can write at last. Wait. First one write down, that is for assign IPv6 address. V6 address. See, write down, draw the topology also nearby. Then only you will understand. So IPv6 interface brief. Okay. And how to add loopback? Interface loopback 1. IPv6 address 2001.1/64. Interface loopback 2. So add like this 2. 3. So 3. 3. Write down the topology nearby and then write it down.
So in topology, R1 is a left side router or R2 is a
R0, R1. Hmm?
no sir. In commands R2, so
Oh, that one. That is your task.
There is no concept of wildcard. No.
Subnet mask itself is not there, then why wildcard mask will come? Written, everyone.
No.
Write down quickly. What's Sri, you had good lunch yesterday? Function. So that's why your parents came. So your sister is living here.
Nearby.
Hmm?
Nearby. Yes.
Nearby. Okay, next thing we are going to learn is campus networks. This is done. See, still, what are the topics left? Um, you have AI. I'll give you a small introduction to it. What is cloud? What is automation? What is quality of service? Okay. What is VPN? Wireless, SNMP, SNMP syslog, slog. IPv6 is your task. It's nothing but IPv6 is nothing but the address which is, if you try to access the DHCP and if DHCP is failed, then you will get the IPv6 address. That address is like
Temporary.
not temporary. With that address, you can't communicate with other network. Within the network, you can ask for IPs and all. So that is called IPv6 address. Okay, the range is 169.254.0.02, 169.254.255.254. Yeah, 169.254.255 dot again 254. So that is the range of IP address. Okay, so AI, cloud automation, quality of service, VPN, wireless SNMP syslog. Anything else left? Automation, quality of service, VPN, redundancy, SNMP syslog. No, that's it. So that's it. So I'll do one thing. So tomorrow I'll let you know in the group. So we will not see all the concepts. Some basic concept we'll see. That is, we'll see what is SNMP syslog AAA. This will hardly take on 30 minutes. Okay. And then we'll discuss what is AI and cloud. Only this much we'll see tomorrow. Or see, only this one is practicals. Only your wireless is practicals. Other than that, everything is theory. So 1, 2, 3, 4, 5, 6, 7 concepts are there. Okay. So what I can do with wireless, I can add 2 more concepts. I will add this SNMP syslog AAA I will add. Okay. Can do one thing. This we can do it on Monday. Along with that, I can add this automation also. So Monday we will discuss this. Okay. So if possible, tomorrow we will have one online class that will be around 1 hour or 1 hour 15 minutes. That's it. So I'll explain you these things. Okay. Only basic level you'll be able to understand in online itself. Nothing difficult. Very basic. Okay. So we'll plan accordingly so that you will not have difficulty when you go to your upcoming batches, because multiple people are having 3 batches. It is very difficult. So only one day you can adjust. Okay. That is you can do. Otherwise, I can do one thing. Tomorrow I will take like 2 hour or 2 hour 20 minutes class and completely I can finish that. But everybody has to come. That is the problem. Of like if see how many people 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm getting up to 15 to 20 students on average. I'm getting offline. So if everybody comes, then only I will take. How many of you are possible to come? Timing I'll let you know, but those who are nearby, it's fine. See, this is the problem. Some are coming from long, they will not be able to come. Okay, Mohammed. So Monday we will have one class. Okay. So practical part we will have Monday. Theory part, if possible, we'll do it tomorrow. Or we'll do one thing. Monday we will have 2.5 hours class and completely we will do it. That is also okay. Okay. I will let you know in the group by tomorrow morning or night. Okay. So now we are going to see campus networks. This is called three-tier architecture. Okay. So I'm having two buildings. Okay. So I'm having a switch, another switch. In this building also I'm having another switch. Another two switches are there. So here I'm having two PCs connected like this. 1, 2, 1, 2. Two PCs are connected. Again here I'm having 1, 2, 1, 2 PCs. Okay. And they are all connected to each other. Okay. And to connect these two switches, I'm having another switch. Again, here also I'm having another switch to connect these two switches. Okay. So what if this switch goes down? Then completely it's gone. So for redundancy purpose, I'm having another switch here. I'm having another switch here, and that switch is connected to again these two switches. And they are also interconnected. Again here, they are interconnected. This switch is connected to this switch. This switch is connected to this switch like this. Okay. So like this, they are connected. Now, to connect two buildings, we are having another switch. We are having another switch. So this switch will, what it will do? It will connect the buildings. And if this switch goes down, again, completely gone. Two building also gone. So for redundancy purpose, I'm having another switch. So these switches are connected to both the buildings. And they are interconnected to each other. Okay. So this is how a real-time architecture will be. Huh?
It's more than pieces.
It is more than
End devices.
more than end device. No, end device, there are multiple devices will be there. Here I have taken only two. Okay. So first you have one layer of switch that is going to segregate the departments. And after that, there will be another switch that will be connecting the all the department switches. And then you have another layer of switch that is going to connect the buildings. So there will be three layer of switches. After this only you will have your router like this. So this router will be connected to the switch, and then it is connected to ISP. Okay. What if this router goes down? Everything is gone. Correct. Everything is gone here. So for redundancy purpose, we will have another router. And this router is connected to this switch like this. Is connected like this. And they are interconnected between each other. So this is how a tier 3 layer of architecture will be. It's called tier 3 architecture. Okay. And the direction, the flow of data will be north to south and south to north. The data will be up, down, down, up, like this. Okay. So this is how a campus networks in your 3 tier will be there. Understood? So what happens is this layer of the switch is called, we have 3 layers. This one layer, you have another layer, and you are having another layer. 3 layers of switch. Tier 3 means 3 layer switches. This is what tier 3, 1, 2, 3. So this layer is called core layer. This layer is called distribution layer. This layer is called access layer. Okay. So in your access layer, your end devices switches are connected. For connecting the end devices, we are using the access layer. In distribution layer, we are creating the policies for the end devices. Okay, like access list or VLAN configurations, all those configurations, filtering. Okay, all those configurations are done in your distribution layer. In your core layer, we are not doing any configurations. I mean, your policies can be created in your core layer, but we are not doing it. Reason being, this tool switches right here, right? They are going to take the load of complete network. Complete 2 building network will flow through this switches. So usually in your core layer, you will find the high-end level switches that can carry more data and bandwidth. So that's why in these layers, we are keeping it as free, because every layer of data has to be from down. If I'm going to access the internet, it will go via this switch. From if ISB is giving some server is going to give any information, again, those information is going to come through my core layer switch. So that is the reason I'm not going to disturb that switch. Instead, I'm having this distribution layer switch. There I'm going to do all my policies. An access layer will divide the departments. That means from PCs to PCs, the end devices are connected in my access layer. So policies are created both on access layer and also the distribution layer, depending upon it. Okay. So this is how multiple buildings are connected to each other. Any doubt on this? This is your yeah, cables and wires. So this is your 3-tier network. Now I'll show you 2-tier network. So 2-tier network is like a one building. So I'm having 2 switches just like that. 2 PCs. To connect this, I'm having another layer of switches. Okay. My ISP is here. Okay. This switch is connected to this switch. And also this switch is connected to this switch. This switch is connected to this switch. They are interconnected to each other. Then they have the router. 2 routers for redundancy purpose. So here one difference you can see, only 2 layers of switches there. Because there is another 3 layer, it is not there because this is a one building architecture. We don't want multiple buildings to connect. That's why we directly have this here core and distribution comes under single layer. So that we call it as collapsed layer. Collapsed layer we say, and this is your access layer. So n devices are connected here. So in your core and distribution layer, that is your collapsed layer itself, we are going to give all the policies. So again here, the flow of data. Data is from N to, yes, that is north to south and south to north. Okay, this is your two-tier architecture because two layers of switches there. Okay, first we have seen three-tier, two-tier. Now I'll show you small office. We have another architecture called SOHO. SOHO. That means small office, home office. That is very simple. That means ISP is there, router is there, and then I'm connected to a switch. So through this switch, there are multiple devices connected, and also I have this Wi-Fi. Imagine this is Wi-Fi. So through the Wi-Fi, multiple devices are also connected like this. This is my Wi-Fi. This is called SOHO architecture. Small office, home office. So simple. We have a router, switch, and then connect it to the devices. This is startup companies always go with this kind of topologies. Okay. And then important thing, that is your what architecture? Any idea? Any idea? Spine and leaf. Where we are using this? Data centers. In your data centers, we are using this architecture. So how it will be? In data centers, you will have multiple servers. Okay. So these are connected with switches like this. Okay. And again, we are having this layer 3 switch. Okay. And how they are connected means so this layer 3 switch is connected to each and every switch of the access layer. This is also connected to each and everything. Okay. So if for example, if I'm going to increase another two more servers, then what I'll do? I'll do it like this. Correct. I'll have two servers and I'll take one more switch and I connect it. Here I will add one more layer 3 switch. If required, I will add one more also for more speed. Because here the speed should be very fast. I will connect it. So again, this will be connecting to here. This will connect to here. We will connect it to here. This switch also is connected here. Here. like this. Another switch I've added. So he'll be connecting like this. This is connected to just like this. Okay. So here one thing that is direction, that is flow of data. Data is what? West to east, correct? And east to west. So the data will be flowing like this way, not this way. So this is more speed. So this up layer is called spine. And this lower layer of switch is called leaf. Leaf. Okay. So this is how the architecture is in there in your real time. Okay. Any doubt on this?
So L3 switches connected to ISP.
No, you will get replay from the L3 switches. So we'll have another routers connected above that. And then from that routers, you will connect to this L3 switch again. Okay. So this is how the architecture will be in your data centers. This topology, this network architecture is called as spine and leaf architecture. All right. Done. This is just your CCNA is over, to be honest. It's over already. These are all small topics we are giving introduction to it. Okay. What is AI should we see now? Or we'll discuss VPN? Or we'll discuss quality of service? We have another 20 minutes. Which one do you want to learn? AI. What is AI? Artificial? Write down artificial intelligence. AI. What is artificial intelligence? Any idea? Any idea what is artificial intelligence? Did I take CDP, LLDP? Cisco Discovery Protocol. Done, right? What is AI? Tell me. Write down for AI. Ability of a machine to perform. Ability of a machine to perform. Learning. Ability of a machine to perform learning, thinking. Learning, thinking, problem solving, and decision making. Written. So, ability of a machine to perform learning, thinking, problem solving, and decision making. Underneath, write down one more thing. In simple, you can say it is to mimic. It mimics MIC. Mimics human intelligence. Okay. So how your AI works means, so there are data algorithms and there are patterns which are already inside the software. So according to that, it is going to give you the data. For example, if you ask ChatGPT, okay, so already there are the datas in the software only. So after analyzing all the software, what is the question you're asking? It is going to give you the answers. So that is how it works. It just tries to mimic the human intelligence. That is how it works. So there is something called machine learning. Machine learning. Write down. It learns from external environment. It learns from external environment. That is fraud detection, and recommendation systems. See, what is this machine learning? For example, if you keep on getting this spam calls, sometimes your iPhone will tell you this is like a fraud, spam. You get that message, right? Spam. So how does it doing? Through your machine learning only. And recommendations, for example, if you keep on watching about shoes, okay, and then if you go to a YouTube, there also you will be getting the shoe advertisement, correct? So how does it doing? That means it is learning your system. Okay, your machine learns your system, and according to what you're doing, that it will give. If you're watching movies, if you're watching crime movies, you keep on getting that crime movie suggestions. If you watch comedy movies, then you get comedy movie suggestion. Why are you all laughing? Huh? Comedy only. In this batch, there are so many naughty people. Okay. So according to our watching things, we are going to get the recommendation. Correct, Srihari? No. I will check your history later. Wait. So this is called your machine learning. Another one we are having, this is called predictive AI. Write it down. It analyzes the historical data and make prediction. Okay, for example, it analyzes the historical data and make prediction. That means, for example, they say it may rain in Bangalore. Correct? Your forecast may say it may rain in Bangalore and you will not get rain. Correct? 100% you will not get correct. That means what? It is predicting based upon the previous data. So if today is there, what is the date today? July? You still on your DHCP class only. Come to AI class. So 11. So what happened on last year 11? That before 11. That before 11. It will see all the historical data and it is going to run through some algorithms and it will give you, okay, according to those details, it will give you, it may rain or not rain. Okay. So for example, another example I will give you. See, during festival times, every bus ticket will go up. Correct? Why? Because they will somehow come to know about, okay, this time everybody is booking ticket. Correct. Everybody is going home and everybody is booking ticket during Diwali time. So that's why the price hike will be there in your festival times. And if you see your shopping Amazon or whatever online thing, the price of clothing will go down. They'll give a lot of discounts because everybody will buy at the same time so that they can clear all the stocks. So how they are coming to know about that? Through the last previous data. They'll come to know this time my purchase have been like this. So they'll analyze all the data and they'll come to a conclusion, okay, this is the best. So those are all called as predictive AI. Then we have, write down deep learning. Deep learning. It is neural network to model complex data like image recognition and language processing system. What is this deep learning? For example, you have this face recognition in your phones, iPhones, all your mobile modern telephones. We are having face recognition. That is through your neural eye. Sometimes you have this eye also, right? In certain phones, there are nowadays. So all those are called deep learning. So your neural network, it will do it and it will model the complex data and it will give you the result. So that is called your deep learning. Okay, and then we have another one that is we are using nowadays. What is it? Correct. Who said that? Very good. Generative AI. That is, it will do, we are already having some basic algorithms. That is, image, text, videos, audio, based on the pattern they have in historical data. For example, it's your ChatGPT. Okay, so already they have this image, audios, videos kind of patterns in their historical data, and when you ask for it, they will going to give you the information. Okay, that is called your generative AI. So another thing is ethical considerations in AI. Ethical considerations in your AI. That is algorithm. Algorithm bias, privacy concern, then employment impact. Write down. Written. So generative AI, we have seen what is this ethical considerations means algorithm bias. So nowadays, even in your resumes, okay, they are filtered by your AI only. Correct. So what they are doing is they'll give these are the topics. If you forget to write TCP UDP, so when you say you completed CCNA, obviously you would have completed TCP and UDP. Correct. So and if you forget to write down TCP UDP, that machine is going to filter your resume. Though you are good in it, that machine might miss your resume. Correct. So those kind of problems we have in your algorithm bias and privacy concerns. Nowadays they are doing uh, this morphing. There is something called this deep fake or something recently. That is the concern now. Correct, in real world. Deep seek, right?
Deep seek.
Deep,
Deep seek.
not deep seek.
Deep
Deep fake. Deep fake only. So they are changing the face. Correct. So they are using it in a different way. So that concern is there because of your AI and voice recognition. Correct. They change. I mean, if I'm saying today's class is from 2:30 to 4:30, then you can change it to night 10:30 to 11:30. Dinesh will do it. Dinesh will do it. So that kind of problem is also there. So that is called your privacy concerns. And third one, employment impact. That is definitely there. Correct. But means, see, your AI definitely can't completely take over the human work, but it can reduce it. Okay. So that concern is always there. So that is the reason we are using this. These are the problems we face in AI. Okay. So this much only we are learning in AI. What is deep learning? What is generative AI? What is predictive AI? Machine learning? What is AI? Okay.
These are connected. CC.
It is not just, I'm just adding. So that some people will not have simply they are saying AI, AI. What is AI? It's nothing but whatever I am saying that is going to reflect it. Already the algorithm which human gave, it is going to perform in such a way. Okay. See, before if I asked what is uh, predictive AI, do you know what is predictive AI? You don't know. So you should know some basic things. So that is the reason I've included this part in your CCNA. Okay. So we have completed AI now. So we have cloud quality of service VPN. So this is like hardly it will take 1 hour or 1 hour 10 minutes something, and then this will take another 1.5 hours. So that's it with your CCNA then. So most probably I can finish it by Monday. Though we have class on Saturday or not, still I'll be able to finish it on Monday. Okay, so don't worry about it. This is actually two hours class. Actually, 2 hours class. So I usually don't take complete 2 hours, 2 hours, 10 minutes. I take maximum 1 hour, 30, 35 minutes only. So that is the reason I wanted to give it in 2 days. And in last day of class, I will give you a pattern how to learn CCNA. So what are the topics covered? So how to prepare for interview? What are the questions that might be expected? Where, highest number of questions asked in which topics? Initially, where they are asking. So those things we'll discuss on last day. I'll give you a complete CCNA kind of roadmap. Okay. All right. So that's it for today's class. Any doubt on your today's class? So what we have discussed today? So today we have discussed IPv6. In IPv6, we are discussing shorten rule, MAC to link local address, a routing of IPv6, how to assign IPv6. Okay. What is a network part, host part? There is no subnetting in your IPv6. So again, in your advanced, you will learn IPv6. Okay. So after that, we have seen campus networks, tier 3, tier 2, small office, home office, and then we have learned this spine and leaf. After that, AI. So this much is enough for today. So I'll end the meeting here. I'll see you guys on Monday definitely. If there is class tomorrow, I'll let you know in the WhatsApp group. Okay. Any doubt online? Online guys, any doubt? No reply. Okay. Thank you guys. I'll see you guys on Monday.
No, sir.
Okay. Thank you.
Okay.